We're going to look at this worksheet together. This is called Writing Data in a Matrix. So far we've been doing a couple of units where we've been dealing with data, right? We've been doing some data collecting and making graphs of the data. We've been using two-way tables and Venn diagrams to understand data. Well, here's another way of organizing data and being able to more easily use it, like in a computer or a calculator. So this is kind of like a two-way table, but without the titles. So we're going to go through this assignment together mostly. I'm not going to do every problem for you, but most of them, and help you understand how matrices can actually represent things. Okay? So we have question 1. The prices of things at 2 supermarkets are different in different cities. Toilet paper in Duluth, Minnesota costs $3.99 a package, while toilet paper in New York City costs $8.95 a package. Duluth, toothpaste costs $1.95 a tube, while in New York City it costs $5.25 a tube. So let's analyze what each row and column in our matrix represents. Okay, so we have 2 different cities going on, and we have 2 different products, right? We have some toilet paper, and that is in Duluth, Minnesota, and it costs $3.99. So you can see right here in our matrix we have a $3.99 in this 1, 1 element, row 1, column 1. So that means that this row or this column, 1 represents toilet paper and 1 represents the city of Duluth, Minnesota. Let's keep reading. Again, we have another reference to toilet paper, but this time a different city, New York City, and that's a cost of $8.95. So notice how that is in this space here, 1, 2. So we have row 1, column 2. So interesting, so far all we've been talking about is toilet paper, but we've mentioned 2 different cities. So that must mean that this entire top row is representing toilet paper. I'm going to abbreviate it with TP. Okay, so right here, row 1 represents toilet paper, right? You can abbreviate it if you want. Okay, we can also figure out now something else about what the columns represent, but let's keep reading and see what we can discover. Next, we have toothpaste. Toothpaste costs $1.95 in Duluth, so that's a Duluth price, $1.95. And then in New York, it costs $5.25, so that's a New York price, $5.25. So now that we have a little more detail, we know that this second row is representing toothpaste cost. And notice how I've been color coding things. Both of these are in red, and I've underlined both of the costs from things from Duluth. So that means that this column is representing Duluth. And then this column right here has the price of toilet paper and the price of toothpaste in New York City. So that one represents New York City, right? So now that we've kind of labeled what the numbers mean, you can finish filling these in to tell me what row 1 represents. We already did that one together. What column 1 represents, what column 2 represents, what row 2 represents. You've got this. So please finish question 1 for me. Okay, now we're going to use question 1 to help us answer the following questions. If the answer is false, we need to explain why. True or false? The following matrix P is also a correct representation of the data in the matrix. It's important to understand that data can be organized in different ways. Like the cities could be in the opposite order, or the products could be in the opposite order. What we can't switch is we can't make it so that a column or a row has a mix of things that it represents, right? We've got to stick to one row or one column for each thing. So if we look at this particular change to our matrix, we'll notice that the only thing that's changed is that these 2 items have traded places. But these 2 items have not traded places. If they both traded, it would be fine. But it's not okay for them to just trade 1, because remember how these 2 numbers represented Duluth? Now Duluth is not in column 1. It's not like a two-way table that you could accurately label with Duluth at the top, because one's in one column and one's in the other column. That's confusing. And then New York is in two different columns now. So we can't identify just one column to represent New York and one column to represent Duluth. So imagine putting titles and seeing if it still works with the same data, and if it does not, then it's false. So this one is false, but I'm going to let you write down your reason. Just we can't switch one number, we have to switch entire columns or entire rows. In this case, it was just one number in each column, right? So we have to switch the entire column or row instead of just one number. Okay, so let's go ahead and write this in a completely different way. We could make the cities our rows and the products our columns. So we could be like, all right, so let's make Duluth this this row instead. So $3.99 for toilet paper in Duluth and $1.95 for toothpaste in Duluth, right? And then we could do $8.95 for toilet paper in New York and $5.25 for toothpaste in New York. So all we've done here is we've traded that the rows are now the cities and the columns are now the products. So toilet paper and toothpaste, which if we wanted to abbreviate has the same initials more or less as toothpaste. We could just call it T. Okay, so that's one way of switching it, would be to actually trade the rows for the columns and the columns for the rows, right? Or another way to do it, based on what they were trying to have us do here, is we could actually trade entire columns instead of just one number in each column. So what if we just did $3.99? Well, I was going to trade entire columns, right? So that's not going to work. So from our original, we're going to trade the $8.95 and the $3.99, and then just like this happened here, trade from up here the $5.25 and the $1.95. And all that's done to change anything is it's traded the two cities in which Duluth, I can't spell it, and which one is column 1 and which one is column 2. And that's perfectly fine as long as you understand what each one represents, right? And then this stayed the same, toilet paper, toothpaste, so as our original problem. So this is just a couple of different ways to make that work. I don't remember how this is organized in the online assignment, but just be aware, be careful. Okay, let's keep going through the rest of our questions. In question 1, because this is all based on the same information. Okay, in letter C, true or false, the second column represents the price of toothpaste in the two cities. So the second column represents New York City, right? It is not the cost of toothpaste, that's the first row. So this says the second column, it's false because it's not toothpaste, it's New York City. Question D, the first row represents the price of toilet paper in the two cities. Did we say that this first row was toilet paper when we did question 1A? Yes, we did. Or just question 1? Yeah, the top row was toilet paper, the bottom row was toothpaste. So yes, that one's true. E, true or false, is element G 2, 1, 195. So 2, 1, that would be row 2, column 1. Is that 195? Yes, it is. True or false? Element G1, 2, is that 525? So G1, 2 is the ones I've marked here in purple. That's actually 895, so that answer is false. And it would be this one I've marked in purple highlight, 895. True or false? A change in the price of toilet paper in Duluth can be represented by the matrix shown here. So what has changed? Let's look at our original. $3.99, $1.95, $8.95, $5.25. Oh, look, that's the number that's changed right there. It's the $9.25. Or the $8.95 has changed to a $9.75. So that is not Duluth. That is New York that has changed the price of toilet paper. H, true or false? If another city is included in the data, then the dimensions will be 2 by 3. So you can see what I've written in red here answers this question. The answer would be true, because right now this is a city, another city would be another column, and that would change the that changes the dimensions on this second column if we add another city to this particular arrangement. If we were to change it to a different arrangement, like we saw on part B, that wouldn't be accurate. But based on what we have here, that is accurate.